Hello, this recording is about using marginal costing in short-term decisions, and the decision that we're looking at is CVP analysis, or cost volume profit analysis. What we will be looking at is how to calculate the break-even point, how to calculate margin of safety, and how to calculate how many units we would have to sell in order to achieve a particular target profit. Starting with break even, by break even we're talking about the number of units we have to sell to break even, and that means we've made neither a profit nor a loss. So at break even point, your sales will be equal to your total costs. So sales minus total costs would give us a zero profit. Now we're talking about total costs, so that is both the fixed and the variable costs, although you will have to separate them out in calculating break-even points. Now there's two ways to calculate break-even. You can either draw up a break-even chart, or you can do it by means of formulae. So we'll start off by having a look at a break-even chart, but we're going to concentrate more on the use of the formulae. So we have our break-even chart. On the x-axis we have units. This is units of production and also units of sale. On the y-axis we have values. So this represents values of production and values for sale. Now we put three lines onto the break-even chart. The first line is the fixed cost line, and this is the horizontal line. So we've got this line here. So we'll go over it in red. So there's the fixed cost line. Horizontal line because as our units of output increases, the cost remains the same. That's the definition of a fixed cost. It doesn't change with output. Remember, we're always talking about short term, that's not indefinitely. The second line we will put onto the graph is the sales revenue line. This starts at 0 because if we sell 0 units, then we will have 0 revenue. So this is this line here. This is our sales revenue line. And then the third line that we have plotted on the graph is a line to represent the total cost. So that is both the fixed and the variable cost. The starting point, when there are 0 units of output, the line will start at the fixed cost, because fixed costs will still be incurred even if we have 0 units of output. So then our total cost line, as our units increase, we have the fixed cost plus the variable costs. So we have this second line that is going up here. So there's our total cost line. Now going back to what I said about break-even, the break-even point is when sales are equal to total costs. Well, we've plotted a sales line. We've plotted a total cost line. Where they are equal, so in other words, where they meet, that is the break-even point. So on our graph, where these two lines cross, that is our break-even. Now we can read the break-even point off the x-axis in number of units, or we can read it off the y-axis as a revenue. Anything that we sell above break-even, so that's here, we know we will be making a profit because the sales line is above the total cost line. When we go below break even, we'll be making a loss because our cost line is above our sales line. So this is the loss-making area. So any point above break even, we can read off by looking at the difference between the two lines, what the profit would be. We could, if we needed to, work out our variable costs because we have a total cost line and we have a fixed cost line, so the difference between the two would be our total variable costs. The other thing we could read off a break-even chart is what's known as the margin of safety. Our margin of safety is how safe we are, so how much above break-even are our actual sales. So once we've identified the break-even point, if we then look at what our actual sales are, or if we're forecasting what our planned sales are, so for example, if I just roughly read off, that's maybe our break-even point. If we're planning to sell this amount, so £11,000 worth of sales, our margin of safety is the difference between these 2 points. So that would be our margin of safety. If we wanted to know how many units we had to sell to achieve a specific profit, remember the profit is the difference between the two lines, the sales line and the total cost. We could then use that to work out specific target profit that we wanted to make. For example, it might be this amount here, and how many units we would have to sell to achieve that target profit. So it is possible to read off a break-even chart all the relevant information. However, it's far quicker to calculate these using formulae. Now you do need to learn these formulae. So the first one that we have is the break-even quantity, and that is equal to the fixed costs divided by the contribution per unit. So I'm just going to highlight these as we talk about them. So break-even quantity, fixed costs divided by contribution per unit. Now that will give us a break-even in terms of units. Now we always round up. So we don't apply normal rounding rules. Whatever answer you get, round it up. Because if you round it down, you won't quite break even. So round up to the nearest whole number of units. We can also calculate what is called the contribution to sales ratio, often referred to as the CS ratio. And what that is telling you is how much contribution you are earning from every pound of sales. To calculate the contribution to sales ratio, you are looking at dividing your contribution by your sales. Now the CS ratio can be calculated using unit figures, so the contribution per unit divided by the selling price per unit, or you can calculate it on total figures, so total contribution divided by your total sales revenue. Whichever way you do it, you will get the same answer for your contribution to sales ratio. Now that ratio can then be used as an alternative method of calculating break-even. So we can have break-even revenue. So this is your break-even in value of pounds. And we can get it by fixed costs divided by the CS ratio. So if you think back to the graph, this would be the break-even point that you would be reading off the y-axis. So it's in terms of a value rather than in terms of units. The other option would just be to calculate out your break-even in terms of units and then just multiply that by the selling price. That would also give you a break-even in revenue. So two ways of getting your break-even in terms of a value. So that's your break-even point. Secondly is the margin of safety. So how far above break-even are our actual sales or our planned sales? So margin of safety, our current or our planned activity minus the break-even activity. And that gives us an answer in units. So how many units above break-even? Sometimes we might be asked to calculate that as a percentage. So once you have that margin of safety figure, you then divide it by your current or your planned activity and multiply it by 100. We will look shortly at using some of these in an example. The next one, target profit. So how many units do we have to sell to achieve a specific target profit? And we have another formula. So the number of units, so the activity level, it's the fixed costs plus the target profit we're looking for, and divide that by the contribution per unit. And that tells us how many units we need to sell. So those are the formulae that you need to know. So now we're going to have a look at applying some of those in an example. So here's our example. So we've got company operates within the leisure and entertainment industry. It is currently considering the viability of running a concert in Singapore. Estimated fixed costs are £60,000. They include the fees paid to entertainers, the hire of the venue and advertising cost. Variable costs consist of the cost of a pre-packed buffet, and that's estimated to be £10 per ticket sold. And the proposed ticket selling price is £20. So we have the information we need. We have a selling price, we have a variable cost, and we have fixed costs. So we've been required to firstly calculate the number of tickets the company needs to sell in order for the concert to break even. So our break-even formula is equal to fixed costs divided by the contribution per unit. So that is fixed costs of £60,000 divided by the contribution per unit. Contribution per unit is the selling price minus the variable costs. So we've got £60,000 divided by 10 means to break even we have to sell 6,000 tickets, because this formula gives us a break even in units, and our units are tickets. Part B, how many tickets do we have to sell to make a profit of £30,000? So this is our target profit formula. So the units for target profit, and the formula for this is similar to the break-even formula. It's the fixed costs, but we add target profit and divide by the contribution per unit. So that is equal to fixed costs of £60,000. We're working out how many tickets we have to sell to make a target profit of £30,000, and we divide by the contribution per unit, which we know is 10. So that gives us an answer of 9,000 tickets. So to make a profit of £30,000, we have to sell 9,000 tickets. Part C is asking us about the profit that we would earn from selling 8,000 tickets. So no formula needed for this. This is just a profit calculation. And the easiest way to do this is to start with your unit contribution. From that, work out your total contribution, then deduct the fixed costs, and you would be left with the profit. So we're selling 8,000 tickets, and we know that the contribution per ticket is £10. So £10 per ticket. So total contribution is 10 times 8,000. So that gives us £80,000. And to calculate a profit figure from total contribution, we take away our fixed costs. So the profit to be made from selling 8,000 tickets is £20,000. And that would seem about right, because we've previously calculated that to make a profit of £30,000 we have to sell 9,000 tickets. So we would obviously expect the profit to be less than 30,000. Right, let's have a look at the next requirement. So we've done part A, we've done part B, we've done part C. So part D, the selling price that would need to be set in order to generate a profit of £30,000 on sales of 8,000 tickets, assuming other elements are as stated above. Now this one is a little bit more difficult because we can't go straight to using one of our formulae. As the target profit formula calculates how many units we would need to sell in order to achieve a target profit. Well, we're told that they want to generate a target profit but we're told that they want to sell 8,000 tickets. So we know how many units we want to sell. We know what our profit needs to be. So we need to work backwards to see what we need to set the selling price at. So what we know is the profit. We want to make a profit of £30,000. We know what our fixed costs are. So now we can work out our contribution. So we're working backwards. Because remember, contribution minus fixed costs equals profit. So if we add our profit and our fixed costs together, we can get a contribution. So contribution would have to be £90,000. We also know what our variable costs are. We're selling 8,000 tickets and the cost per ticket is £10. So our variable costs are 80,000. Now sales minus variable costs equals contribution. So therefore our sales must be £170,000. So we can just check this. Sales of 170,000 minus variable costs of 80 gives us a contribution of 90,000 minus our fixed costs gives us profit of 30,000. So we've worked out, in order to achieve a £30,000 profit when we sell 8,000 tickets, our sales revenue has to be £170,000. That's in total. So the final thing we can do is work out what the selling price of the tickets have to be. So we've got £170,000 of revenue. That's for 8,000 tickets. So therefore we sell our tickets for £21.25 each. So we've worked out the selling price of the ticket. Now that's not the only way that you could approach this particular part of the example. You could have used the target profit formulae and rearranged it. Now for some of you who may prefer that method, I will run through it, but don't worry if you're not so keen on this second method. There is no definite way of calculating these, just so long as you can come up with the right answer. So the target profit formulae, we know it's the fixed costs plus target profit divided by the contribution per unit. And what this tells us is how many units we need to sell to achieve the target profit. So if we put into this what we know, well, we know the fixed costs are £60,000. We know the target profit is £30,000. We know that we need to sell 8,000 units. What we don't know is the contribution per unit. It's no longer £10 because the selling price is no longer going to be £20. We're having to change the selling price, and that's what we're trying to find out. So we're In order to find out the selling price, we need to find out the contribution per unit. So if we now rearrange this, contribution per unit is equal to 60,000 plus 30,000 divided by 8,000. And if we work that out, that gives us a contribution per unit of £11.25. So that's the contribution. Selling price minus variable cost equals contribution. So selling price minus £10 is equal to £11.25. So therefore, the selling price is equal to £11.25 plus 10 gives us £21.25 per ticket. So an alternative method of arriving at the same answer. Either method perfectly acceptable and either method perfectly correct. So whichever you prefer. Right, there is just one part left to this example that we were looking at. Part E. So we've done part D. Part E, how many additional tickets would need to be sold to cover the extra advertising costs of £8,000. Advertising is a fixed cost. So it means that our fixed costs, which were £60,000, will now be £68,000. So if we work out a new break-even point and compare it to the old break-even point, we will know how many extra tickets that we will need to sell. So if I do this over here, part E, so the break-even will now be £68,000 of fixed costs divided by the contribution per unit, which is 10. Remember, that's your selling price minus your variable cost. So that gives us a break-even of 6,800 tickets. So when we've got an extra £8,000 worth of fixed costs, our ticket sales have to go up to 6,800. Previously, they were 6,000. That's what we calculated over here. So we're selling an extra 800 tickets. So to cover the extra fixed costs of £8,000 would require an extra 800 tickets to be sold. So let's run through using some of the formulae. So you really need to learn these formulae and then have a go at applying them to a number of examples to make sure that you're happy with using them. And as I said, you need to be familiar with a break-even chart, but unlikely to need to draw one up. So thank you for listening. I hope this has been useful.